AMD quietly removed a security feature from its consumer CPUs. No announcement, no patch notes. Users only found out because they started digging. The feature is called TSME. That stands for Transparent Secure Memory Encryption. It's a hardware-level function built into AMD processors that automatically encrypts the data sitting in your RAM, and the key word there is transparent. It works in the background without you doing anything. Your operating system doesn't need to support it. Your apps don't need to know it exists. The CPU just handles it. So why does that matter? Think about what lives in your computer's memory at any given moment. Passwords, encryption keys, personal files you've opened, browser sessions, everything your machine is actively working on. RAM is fast and temporary, but while it's there, it's readable. And there's a whole category of attack built around that fact. One classic example is called a cold boot attack. An attacker physically removes your RAM sticks right after your machine powers off. Memory chips retain their data for a short time even without power, especially if they've been cooled down. The attacker then reads that data on another machine. With TSME enabled, what they pull off those chips is encrypted gibberish. Without it, it might actually be useful. There are other scenarios too. Direct memory access attacks, where a device plugged into a port reads system memory directly. Virtualization environments where one tenant on a shared machine could potentially peek at another's memory. TSME was designed to make all of that much harder by default. Now, this wasn't some obscure toggle buried in advanced settings. AMD had been advertising TSME as a feature on its consumer Ryzen processors for years. It was part of the pitch. Security-conscious users, small businesses, privacy advocates, they chose AMD partly because of this. And then it was gone. Here's what makes this particularly frustrating. AMD didn't announce the removal. There was no security bulletin, no changelog entry, no blog post. Users discovered it was missing when they went looking, either through benchmark tools, firmware inspection, or just noticing that the feature flag no longer showed up in system readouts. That's how quiet this was. AMD hasn't given a clear public explanation for why the feature was pulled from consumer chips. The company has said TSME remains available on its enterprise and server-class processors, the EPYC line, which is interesting because that tells you the capability isn't gone from AMD's silicon entirely. It's been deliberately withheld from the consumer tier. That distinction matters a lot. Enterprise customers often have explicit security requirements, compliance frameworks, contracts that specify what features their hardware needs to support. Consumer customers generally don't, and that might be exactly why AMD felt safe making this call quietly. Most people buying a Ryzen chip for a home PC aren't going to notice a missing memory encryption flag, but some people will, and those people are not happy. Security researchers have pointed out that this kind of silent removal sets a bad precedent. When manufacturers can quietly pull hardware security features without disclosure, it makes it much harder to reason about what your system actually protects. You buy hardware based on a feature set. That feature set should stay stable, or you should at least be told when it changes. There's also a supply chain angle here. Businesses that bought consumer AMD hardware specifically because it listed TSME support now have machines that don't behave the way they expected. If those machines were part of a security posture or compliance review, this is a real problem. It's not theoretical. Some users have speculated that the removal is performance-related. Memory encryption does carry a small overhead. The CPU has to encrypt and decrypt data as it moves in and out of RAM. On workloads that are extremely memory-intensive, that cost adds up. It's possible AMD made a calculation that consumer benchmarks mattered more than a security feature most users didn't know they had. But that's speculation. AMD hasn't confirmed it. Others have suggested it could be related to compatibility. Certain software or hardware configurations can behave unexpectedly when memory encryption is active. Disabling it by default or removing it entirely reduces support headaches. Again, that's possible. But if that were the reason, you'd expect AMD to say so. What we're left with is a company that removed a meaningful security feature from its consumer products, did it without telling anyone, and hasn't offered a clear explanation. That combination is what's driving the backlash. It's not just about the feature itself. It's about the transparency or the lack of it. For most home users, the practical impact is probably low. The attack scenarios TSME guards against require physical access to your machine or sophisticated local exploits. If you're not a high-value target, you're probably fine. But for power users, IT professionals running mixed fleets, security researchers, small businesses that rely on consumer hardware, the calculus is different. These are people who made deliberate choices based on documented capabilities. And they deserve an actual explanation. AMD has a reputation for being the scrappy, user-friendly alternative in the CPU market. Moves like this chip away at that reputation. The community is watching how the company responds, and so far the silence isn't helping. If you're an AMD user and you want to check your own system, there are tools that can read your CPU feature flags and show you what's active. It's worth knowing what your hardware is actually doing, especially for anything security sensitive. We'll keep an eye on whether AMD issues a formal statement. If they do, we'll cover it.